They have a fifth of the x86 compute on the planet. They have a network 6 times the size of this other network you've heard of called the internet. They're putting 30 tons of net new disk in the data centers a day, right?
30 tons?
Tons, like it comes on freaking rail cars, right? Like it is very, very big, kids.
Hello and welcome to Committing to Cloud Native, the podcast where we talk about taking things from the ground and putting them in the cloud and then committing to it. I tried to talk about going astronomical in that opening reference, and we'll get to why that was really cool later. But first, I want to introduce the panelists. So there's me. Hello, everyone. Richard Littauer. And then Justin Dorfman.
Hey, everyone.
Curiefense updates. All right. So first off, we are migrating our site to Jekyll. Basically, what happened is we realized that we wanted to have edit this here on the site. And so we moved everything from a proprietary system, to an open source Jekyll GitHub Pages-esque site that will be live soon. It means the Catacode lessons will now be embedded and not require a sign-in. We're just finishing up our QA. Should be live by the time that this hits the air, which means go on now to see the live open source website. Thank you so much. We have an amazing guest today, Miles Ward. Miles, how are you?
I am groovy. How are you?
You are groovy. I am too. This is the best. All right. Podcast over. Thank you. No. Okay. So Miles Ward joins us today. He is the CTO at SADA, which is a cloud strategy provider. Is that a good way of saying it? Is there a better way of summarizing what SADA is at the moment?
Sure. We're Google Cloud's #1 resale and implementation partner. So there's over 1% of Google's cloud business flows through our company, where we help companies go be successful with that tech stack.
Do they fly you on private jets to say thank you?
I used to use a service called Surf Air, which is in fact private jets. And it took me from Santa Barbara up to headquarters so I can go make fun of Eric and the co. It is a way better way to fly. I'm sort of stunned that we haven't all figured out that this sort of commercial aircraft really suck. And hopefully this COVID thing will teach us all that we've got we need all a little more space. Being stacked on top of each other is a little gnarly. But no, they don't come and thank us. Instead, they say, hey, do 4 times as much, please, thanks.
Yes. Get yourself with AWS and we'll really love you.
Mush, let's go.
So Miles, we're calling today from Palm Springs, and you haven't been with SADA forever. Before you were with SADA, you worked for Google for a while. You also helped NASA with the Curiosity Mars Rover landing, which is the coolest thing ever. I want to talk about that. It
was a real trip watching the Perseverance landing because I was in that room. Like, I remember the last time. Let's see if they don't screw this up. Right? It's the same deal where they had to land with the skyhook, where they call it the scariest 7 minutes in space, fling this freaking robot over the shoulder past Earth towards moon and then out to Mars. And you don't want to damage the delicate infrastructure, right? So this thing has to land soft. You're ballistically launching something the size of a Mini Cooper at another planet, and it has to just touch down cozy So they lower with this rocket system that's counter retro rockets like the SpaceX rockets are doing. But you can't have dust in the way. So it's on ropes and it gets lowered while this thing is air braking. And then right at the last minute, it releases the ropes and throws this thing out of the way so it doesn't crash on top of the super precious robot you just landed on the planet. It's the most convoluted, complicated, harebrained science fiction thing I've ever heard of. Much, much harder than just streaming their bytes over this handy dandy internet work.
I did not know that's how it worked.
Yeah. It's a hot mess. It's totally insane.
I just started The Martian again for the maybe 80th time now, the audiobook. I just really like it. I've heard it described as competency porn. It's just a dude being competent over and over again. And it's just really exciting to read about. It's kind of what your bio sounds like to me. Not to be too complimentary, but tell me what you do at SADA.
So I'm Chief Technical Officer, which is the other phrase is Chief Tuba Officer, which is, I think, a much better use of the acronym.
Pointing to a tuba behind him.
Yeah, the SADA helping companies implement Google Cloud Platform and migrate to it and mature their technology, upgrade their infrastructure, and frankly, in a lot of cases, become more cloud native is the center of what we do. And so my responsibility is making our engineers and delivery folks, solutions architects, customer engineers, all the folks that are helping people do that in technology, help them be successful and have fun and make it so that companies have a great time. So it's absolutely a spot where we're in the place where the rubber meets the road. When I worked at Google, I spent 5 years there. I built the solutions architecture function at Google Cloud and kind of was the top point of technical escalation in the sales and go-to-market functions there. So the big part of that was kind of writing down the instruction manual. Here are the best practices. This is the snazzy little architecture diagram of what it is you're supposed to go implement if you're going to follow the rules. I built the architecture diagram system. That's my gig. But the diagram is not the thing working in your platform and does not actually have to go through all the rigors of actually deploying the thing. Yeah. So SADA is at this spot where I take the recommendations I used to give and we just go do them. And we're the ones who end up doing the kind of last step, the final last mile, or however you want to think about it, where this thing actually turns on and does what it promises to do. It's fun.
So before you were at GCP and wrote all this, was there another company you were at that
ran a team? I wrote a bunch of it, but ran a big team of really smart, lovely people that wrote a bunch too. Right?
Yeah. Okay. Thanks for clarifying that. Yeah. But
like, we've actually 400 solutions in 4 years.
Before that, what was your experience with any cloud provider, whether it be GCP or AWS?
Yeah, I was the 5th solutions architect at AWS. Hey, we should call it solutions architecture. It'll be awesome.
Do you know Jeff Barr?
Yeah.
Just so cool.
When I started at Google, Boris Holtzley asked, hey, what do you want to do here? And I explained with a bunch of convoluted words. And he goes, hey, can you just be Jeff Barr? And I was like, oh, I love Jeff. Jeff's rad, but that's like writing blog posts all day. I'd like to, actually do stuff. And he's like, great. If you could just be Jeff Barr, that'd be awesome. So, and fast forward, like years later, he's still pestering me. Everyone's like, could you just do the Jeff
Barr?
So there's no replicating him as a superstar. I'm also
you can't.
A big fan of one of his compatriots, Bob Culver, who built the original, your purchases used to look like this rectangle, and now you can auto scale because cloud is great. He's the inventor of that viewpoint and a bunch of other awesome stuff. They're great compatriots. But Amazon, I spent, I built a startup and it was terrible. And we vaporized a bunch of shareholder value. It was outstanding. But in doing so, we evaporated every different terrible data storage system in the world. Broke MySQL, broke SQL Server, screwed up. There was this new Postgres thing. We made fun of that. It didn't work right. We read papers about Hay-doop and deployed Hay-doop at scale, only like 4 months later to realize that we were pronouncing it wrong and we didn't know what we were doing. And Hadoop is kind of a cool thing now. So, all of that crunching, horrible experience trying to do a little tiny fraction of what Google does by organizing and making useful a subset of the web meant that I had all this experience that the Amazon folks thought was kind of interesting. They're like, all of our startups are doing the dumb things you were doing. Can you talk to them about that and help them be successful and maybe dive in and see if you could build that over again on cloud? And I was like, do you have M1 larges with 8 gigs of memory? 7.5, in fact, like not even a whole 8. What did you do with the other half gig? And my startup's built on a bunch of prototype Dell R910s with 256 gigs of RAM. I can't build my startup on your tiny, girly little computers. So, I was re-educated. It turns out like you can build awesome big stuff with little tiny building blocks. And now, of course, Amazon has bigger computers than anybody can get their hands on, right? They've got machines now with a terabyte of memory on ARM. So the world has changed a lot in the 12 years since I started in cloud stuff.
And you used to be at Twitter, if I am...
No, I have a bizarre relationship with Twitter. So
interesting.
The startup that I built, we were one of the first companies trying to figure out and how to understand and measure and quantify the relationships inside of social media. This is before they were calling it social media, before Twitter and Facebook were founded. So we were basically screwing around with blogs and forums and stuff. And then there's this really weird blog with really short blog posts that comes up and it screws up all of my data indexes because the volume of posts is very high and I'm used to like lots of text and they have like very little text. Screwy blog. I hate this thing. And they've got developers that are actively working on it. It's not whatever one of the forum engines or WordPress or something where I have a pre-built parser that knows how to do it. They're changing the front end of Twitter every 30 freaking seconds. And so I'm constantly having to rebuild parsers. And there's a product called, what did it used to be called? But basically it was a way of getting B-block diverse IP address proxies so that you could go hammer away at sites that want to block you by IP. We were the second largest customer of that product behind the CIA. So we're attacking effectively Twitter in incredibly violent ways to get at as much of the feed as possible. And their response was to build the fire hose. They were just like, please stop hammering our front end. We'll give you an API, shove off, right? So in doing that work, we also had to get information from the search engines constantly in fighting with the Yahoo API and beating up on what had just started at Bing. Really, people are reading Bing. Okay, fine. And the Google site was the same, changed every 30 seconds, super hard to parse, difficult. And whenever we would sort of try to get in there and get more data than the Googlers would come mess us up and straighten us out. So I had a little number in the back. I'm like, I got to go work for those guys at some point because they kicked us all over the map. And I would love to sort of meet the guys that thwarted us in battles or the deal. So I spent this time in Amazon helping figure out how cloud worked and explaining a bunch of that and walking through what best practices were going to look like and plugging into a bunch of the big, hairy customers. And the result was really incredible, right? Like in the period of time that I was there, that product grew 100-fold.
Whoa.
80-ish million to 8-ish billion in revenue. And as a part of that, I met Eric Schmidt through the Obama campaign. I worked as a part of the 2012 OFA team to help design the data infrastructure for processing all of the campaign ads and analytics and all the rest of that stuff. And this old guy that I think I recognize, but I'm not sure, he comes into this room and he's like, why aren't you doing this on App Engine? I'm like, App Engine is a tinker toy. What are you talking about? And like total knockdown, drag out fight all over a whiteboard, beating a bunch of stuff up. And it's like slowly cluing in, like, I think I've seen this dude on CNN and I think I'm making horrible life choices. What have I done? So he introduces me to some buddies, Tommy Kershaw, who was incredible, and then eventually in through to Urs and co. And they're like, why don't you come help? Let's go do this on the Google side. That's now 7 years ago. And it was kind of the same thing. Google revenue was pretty small. And in the 5 years that I was there, we grew at 112-fold. It got a lot bigger. And Andy Jassy had this quote at one of the reInvents. I presented, I think the first reInvent had 60 sessions and I did 7. So there was a lot of content out there. And Jassy had this comment where it was like, look, really, the biggest impediment to AWS growth is the lack of a viable competitor. If only we had a real competition, then companies would have multiple options to select from and they would be able to move to cloud more quickly. So I took that as a personal challenge.
I'm curious. So it's a ton of history here. Super excited. It's blowing me away. But one of my main questions I have is you went from Google, you were there for 5 years, you did a ton of awesome stuff. Yeah. Now you're at SADA. Why switch? Why not stay in Google?
So Google's incredible. You're going to build a startup, right? Every one of these little departments and divisions, they're their own little startup. And you now officially have the coolest garage in which to build a startup that there has ever been. They have a fifth of the x86 compute on the planet. They have a network 6 times the size of this other network you've heard of called the internet. They're putting 30 tons of net new disk in the data centers a day, right?
Wait,
like, 30 tons, like it comes on freaking rail cars, right? Like it is very big, kids.
Wow.
And so as a result of that scale, all sorts of weird experimental stuff that you might think about doing is just, well, of course we have the gear for that. Like that part. Right. We were working on the project to work with Twitter to help them understand, hey, look, we can handle it, right? And they're like, look, we're Twitter, we're real big. I'm like, yeah, adorable. And they go, look, we have 330 petabytes in our Hadoop cluster. We think we run the largest Hadoop cluster in the world by a long shot. They go, oh, right on. So for folks in history, there's a white paper from Google called MapReduce that gets released by the incredible work from Jeff Dean and co. And
the industry is born.
Oh, yeah, no, absolutely. Doug Cutting at Yahoo goes, well, this is hot. Let me see if I can sort of re-implement this. He chooses Java because, I don't know, he doesn't like himself or something. And the result is, it's like a multi-billion-dollar industry, like a giant thing. Saved my startup, right? Set us up to be able to do incredible stuff. And I think that you have to imagine that white paper comes out, one, after Google feels like they have built a successor to it that's better. And they also built another successor to that one that was better than that. And that's the product that we ship to customers now as a Google service called Dremel that's now externalized as a product called BigQuery. So we run Hadoop tests all the time. And then you can kind of squint back at old performance test logs because they don't run MapReduce anymore inside Google. But MapReduce is faster by a lot. And so we're telling the Twitter folks like, hey, no, I promise, bro. It's going to work great. Why don't you come on over? And they're like, well, but we're not sure you're big. We have serious requirements. I'm like, oh, okay. part of their test is to figure out kind of how much gear we can swing around. What can we provide? So they say, we want to know how much local solid state disk we can attach to clusters to be able to run a scaled performance test. We're like, well, sure. Like, how much do you need? They say, well, you kind of tell us what's possible. We run as much of our stuff in local as we can. Could you bring online a petabyte, for example? And for context, because of replication and all of the work that's done internally at any of these systems, 1 petabyte is not 1 petabyte, it's multiple petabytes. And a petabyte of solid state disk is 0.1% of the global production of that type of equipment as of that day.
Got it.
An incredible amount of infrastructure. It weighs a lot. It's racks after racks of gear.
30 tons?
It's more, well, so magnetic weighs a lot. Conveniently, SSD weighs a lot less. So we ended up looking inside on the Google Cloud side and working through capacity planning and thinking through what it would look like. And the question was like, well, I don't know. I've turned on that much in other customers before, but what do we have for demo purposes? What can I give to them to use? And they were like, well, 1, 10, what do they need? And you're going like, hold on a minute. 10 petabytes of SSD as of 2016 is an absolutely galactic amount of infrastructure. So in any case, that ability to bring to bear just an unbelievable amount of hardware to problems, big and small, does magical things. So I spent a bunch of time with the Pokemon Go folks. They gave us, hey, here's this curve. Here's how much traffic you're going to use. And there's this really like worst case right here. It'd be super gnarly. It's going to be like this. And we're like, okay, totally cool. And they used 53 times that much in a week later.
Yep.
Right? Like totally terrifying growth. At the peak of that, they're slightly bigger than Gmail.
Wait, Pokemon Go?
Yeah. Oh, yeah. Right.
Whoa.
So hold on. Where exactly can you pull around enough infrastructure and connectivity and the operational logging on that, like just the log flow out of that many instances? And at the time, they're running on Kubernetes because they're doing what we tell them to do and they're following best practice. Well, there's a maximum node count for Kubernetes at the time. They only have 1,000 hosts in there. Well, they're going to use more than 1,000 hosts. So Luke Stone, incredible operations lead, did a bunch of the Gary work. Henry Robinson was working on it too, a bunch of other heavies, just helping them think through like the migration from Kate's 1.4 to 1.5 in flight while under load, while growing. Like that's hot magic. It's really hard to pull that kind of stuff off in environments where you just don't have all the superpowers that Google's got.
So that's why you would stay at Google, which is great.
Sure.
Why would you go to SADA?
Yeah. So all of that work that I'm talking about, every one of those sort of direct engagements, I'm just ever so slightly outside of what my bosses would say that I ought to be doing.
So why would they let that happen? Why wouldn't they keep you internal? Like, why would they let SADA exist?
Oh, they love SADA. So they're stoked. Right now, I'm telling you a story and walking you through the details that would be difficult for me to say on stage at a Google event as a Google.
Fair. Yeah.
Right? I've got a $1 trillion business that is very powerful and it does not want to shake its foundations and is really interested in making sure that people are happy. I'm a little tiny company by comparison. And we have a bunch of freedom to dive in with customers hands-on in a real deal way. And I don't have to sugarcoat or half measure any of it. And to be really tactical, like really clear about it, there's an enormous amount of direct risk when I'm the one who pushes the magic button on your stuff. And if I'm a Google engineer with access to G3, the core central code base, the multi-billion line mono repo that holds the source for search and the source for MapReduce and every other thing, if I like do the wrong commit and push some of the code in my repo into your repo,
it's bad.
It's extra bad, right? So it's very, very, very useful to have a third party that sits in between that can take on contractual complexity that's difficult for a big macro business to handle, that can assign engineers full-time permanently, don't move them off, are able to sort of stay focused on that.
Got it.
And can do stuff like there's a pretty good handling. In fact, I think the best of the hyperscalers interaction with open source, but we can really participate in those communities and plug in. So it's just a spot where what we have found generally is that in the aggregate, CSAT is better. Customers like this way. So the result is the combination is better than the sum of its parts.
So what are you doing with your extra powers, with your ability to be on the outside? What are you most excited about right now?
We're doing all sorts of stuff. So one of the big ones that I think is a real opportunity, we spend a lot of cycles thinking about the financial operations. I know it's not as technical as you may like, but the reality is
give it to us.
Utterly depend on the financial details. And as the guy who built the pricing calculator for Google Cloud, because I was so frustrated about this stuff, it's just ultra important to be able to boil down and really lay into what is it going to cost? How long is it going to take? What are the risks associated? What's the error bar for that? How do our choices affect those costs? If I move from this product to that product, what's the delta? Those kinds of pieces are really important. And where I think internally at Google, you're watching a bunch of customers do those implementations, but because of those impediments for being hands-on with customers, you're not the actual ones off doing it. They build the product. They don't use the product all day. So we use the product all day. And the result of that is I think we're building a repository of information about its use that's going to really help people make better choices, have a clearer idea of how this stuff works. So we're partnered up with a bunch of companies that help with financial operations and financial analysis to help think through how this stuff makes sense. It's a spot where there's a lot of room because I think in your guys' area in cloud native, there's a bunch of confusion. Is it cheaper to run on Lambda or not? I don't know. That's tough, right? Like or cloud functions or whatever system you want to run. They use so many different pricing models. If you're a business spending millions of bucks, you don't know how to compare these things against each other. You're not sure what to tell your developers to go do. Am I about to shoot my foot off by saying we get off of VMs? I don't know, right? Like a bunch of noise about this container thing. Is that actually a good idea? Does it actually save anybody money? So that's a spot where we spend a lot of cycles.
So I may be outing myself as a newbie who just likes reading books here, but like Nassim Taleb, Black Swan, how do you plan for weird stuff that might happen, which you can't plan for when you're doing stuff at scale? You just mentioned the Pokemon Go instance, right? Where they said, we need this much. And then, 53 times as much. Everyone is out there losing all their money catching Pokemon. That's great. Since you spent a lot of time in the weeds here, do you have any advice for people who are interested in seeing outliers for cloud native stuff and how you would plan for that?
Sure. I mean, I think there's a couple basic pieces. One, 90% of the weird stuff people don't notice because they're not logging. You have to actually write down what's happening in your infrastructure if you have any shot at figuring out what the heck is going on. And there's a whole huge piece of work that's going on in observability engineering and ops theory around that stuff that I think is helping people identify that they are in an unexpected event, let alone be able to do anything about it. I also think the classes of unexpected events, some of them are weird, but it doesn't harm you. You really want to focus in on the ones that suck. And there's this giant swath of them, right? Like for the folks that are coming from data centers or coming from co-location facilities or the others, OVH just had a giant fire, an entire data center burnt down. And HugOps, I feel like we had fires at Google data centers too.
Like an actual fire?
Like an actual towering inferno. Those computers are gone.
Oh, wow.
Yeah, scary. So Google had one where a diesel generator just vaporized a bunch of diesel and just decided to be a fire cannon to the sky. It was great. So those kinds of incidents, when you are running direct infrastructure, they are your problem. and so you are paying to get out from underneath that problem, and you're doing the system design research to figure out what's the most efficient way, given your constraints, to minimize those risks. And you have not enough data. You build your own first data center and you're there trying to figure out whether you want to make a second one, if that's the best way to mitigate the risk. You have the data points you've collected for your business for that. Like super conveniently, the hyperscalers have more than one user. In fact, they have millions of users and they have millions of workloads and they have all of the operational experience of running those kinds of things for decades that makes them make these decisions just frankly much more efficiently. So for example, we spent a bunch of cycles working with a customer in high performance computing. It was like, look, we buy the fastest Intel processors they are. We want the highest clock. That's what gets us to price performance. And our engineering leadership said, no, it doesn't. You're wrong. Love you. But we're running this a couple hundred times bigger than you are all the time. And the reality is at price performance, given network density, you should buy the price efficient chips, not the highest clock chips. And we're happy to model that out for you and show what it looks like. They're like, bull. And we go through a whole bunch of testing and POCs, and here's the results. Like, sorry, we've done this a couple of times. This is how it works. And those lessons are expensive to learn. And Google has spent billions learning them. And you don't want to have to spend billions to cheat, right? My mom can write a website that's cat pictures or some BS and stick it in GCS. And she stands on the global Colossus storage infrastructure and the Band-Aid front end layer and all this super hairy code-based management of infrastructure for which she pays a fraction of a penny, right? It's too good.
So Earlier you mentioned the CIA and you're talking about data storage sites in the desert and diesel generators exploding, which I haven't heard of. And that just makes me think of the Army, frankly. So I'm curious, does the military use this sort of stuff as well? Like, is that one of their main clients? Is that one of your clients?
Main is tough. SADA doesn't work with military companies today. And I think Google has had some positives and negatives. They've announced a couple of contracts where that's happened. I think the biggest and most visible of the public cloud participants has been really between Amazon's Govcloud. And that was really sponsored by NASA. I was a part of helping push on that. And what that created was basically compliance with a bunch of regulations from the government. The root of them is a thing called ITAR that says if you're going to make weapons, you're going to want US citizens managing said weapons. And you want to think of encryption as a weaponizable technology. So all of a sudden you're like, okay, look, we have to manage this in a way differently than hyperscale providers who are used to global, non-country centric kinds of deployments would normally approach that stuff. So it's been a lot for these companies that are Google serving 9 different products to 1 billion users around the planet. They don't pay a lot of attention to the jurisdictional boundaries of individual spots. But then all of a sudden you've got a government that says, no, it all has to be right here. And super conveniently, like there aren't that many tightly bounded problems in computer science. And this is one of them. They don't make new countries all that often. There's only 192 of them. So, okay, just got about 160 more countries to put regions in, and then you're done. You've completed the process of being in every jurisdiction, right? So
unless you go to Mars.
That too. Like we're in talking now with the folks at Johnson Space Center about using Kubernetes on the moon. Like I joke you not.
Wait, for real?
Keep going. How does that work? Why?
Well, you got to deploy code, right? Someone's got to build stuff. How are you going to do it? You want to have it be slow? I don't think you do.
So are you talking clones? I mean, are we talking about having facilities on the moon at this point? I'm very curious.
I mean, there's a lot of work in trying to figure out how to do large scale computation and not having to deal with the totally insane latency and bandwidth constraints from space to not space. So if you've got a bunch of science instruments and you want to grind a bunch of math and you don't want to put a bunch of ML processing on a satellite or some action, you want to stick it someplace where it's not going to wiggle around. The moon seems like a pretty good spot. So there's a bunch of proposals for this stuff. Everybody's looking through different ways of being able to solve for the hard problems in science, the hard problems in business. And I think what's happening is the technology gets easier every year and the barrier of entry goes down. So every year you're going to hear some new wacky science fiction sounding thing that we're going to chase down to try and make so we have a big impact.
So I used to work for IPFS, the Interplanetary File System. And I'm curious what you think about decentralized systems and like how that's going to go in the future. Because it's obviously kind of similar to cloud native, right? It's like doing all this stuff somewhere else, except instead of having it in a data center, it's supposedly everywhere else in the world. Really, it's Bitcoin mines. But anyway, what do you think about that?
So we spent a lot of time, and I think that the technology in the center of a bunch of those efforts is really brilliant stuff. And what you're trying to do is the same. I think the clearest breakdown of this stuff is the Kubernetes operator model. I know that there are humans doing operations tasks. How do I automate those tasks? And to just rationalize it about in the way that like, yes, there's someone doing the operations. What are the operations that they're doing? And how do I program out as many of the fault mitigations and reactions to stimuli that will allow us to build a system that reacts well? All that is great. The unexpected externalization, the consequences of a bunch of that stuff has been really weird. Like I'm not stoked that Bitcoin uses more energy than Argentina. That's extra bad. And I think that conflating what has happened in implementations with the innovation that are happening in the technology, that's silly. We should break that down. And there's a bunch of, I think, really smart stuff going on in trying to help people build increasingly decentralized systems or systems that allow them to interoperate more clearly. I think openness is critically important. I think helping more and more of the technology that we depend on be transparent and observable and people can understand what the heck is going on. I think that's pretty critical stuff. But the real expectation of consumers, of businesses, of my mom and my dog, and like, they want these things to work and they want them to be cheap and reliable and consistent. And they have unbelievably high expectations. I was in Gmail today and I was typing up a note and I hit send on it and it blinked and it seemed like it wasn't going to send for about 4 seconds. And I was like,
I'm really sorry to hear that. That sucks.
And I run the largest G Suite reseller in the world. I'm like, oh, this is important, right? Like I'm over into the dashboard taking a look like, is there anything actually going on? No, it's just my pesky home internet sucks. And but like, if that's my expectation and the alternative, what we're trying to propose is that a cabal of really smart, hardworking, open source people are going to keep up and contribute enough code and do enough of the operations testing and have the infrastructure to do that in comparison to a company with $100 billion in gross profits, right? Like, I don't know, that's tough. And I think that there's a lot where, working together with those communities to help externalize some of the smart stuff that gets come up in the mad rush to serve customers and build the things that they need. I think that's a path to move stuff forward, right? All of us benefit from TLS. We're all super, super protected by the sweet magic of SSL. That didn't get built because people were kind of figuring it out on their own. No, they were like hardcore commercial transaction reasons for building that security technology. And it got done on purpose by big companies. And then, yes, folds its way out into everything. So we all benefit.
Nice.
So we started this podcast by talking about the really cool stuff that you were doing with the rover on Mars. I just want to get back to that because I think it's just the coolest thing in the world. How did you get that gig and what exactly were you doing besides just knowing Eric Schmidt? What happened?
So the NASA stuff is, NASA is a customer at Google too, and I help them here. But at the time, the rover was done on AWS. So my wife and I are literally solar powered. I grew up in Seattle and I just got tired of the rain. And so we interviewed and looked at spots and we liked Santa Barbara. So we moved to Santa Barbara. And I asked my boss, I was like, hey, I think I'm going to get a different gig if you don't let me move to Santa Barbara. He's like, I don't care where you work. You're awesome. Rock and roll. So, great. Now I work at Amazon in Santa Barbara. That's going to be awesome. And I'm like, I'm out of headquarters. Not sure if I'm going to get the hardcore projects. I hope I haven't made a horrible life choice. And it's like weeks after that the folks at NASA who run a thing called NASA TV that runs a live stream all the time. And that stream has students and museums and educational facilities. They log in to sort of look at that stream and sort of check out what's going on at NASA. And at any given time, it has 400 or 500 viewers. It's not YouTube. And part of that is a set of the way that they had designed it. They had bought hardware streaming appliances that they used to vend that stuff out. Well, at some point, somebody decided to loan that hardware to somebody else. And they didn't really have it anymore, but it was okay because the hardware was designed for 10,000 viewers and they only really had 500 viewers at a time. So they were actually vending the viewing stream out of a set of Mac Pros, 2 of them. No problems there. So my role at Amazon, a part of it was working in the partner organization to help ISVs work together and get to working on our platforms, right? So I had worked with Adobe. I helped them design, and I bear scars for the fact that there is MongoDB behind the user login systems for Adobe Creative Cloud. That's my fault. I'm sorry. And but Adobe's on board. And one of the products that they have is a thing called the Adobe Live Streaming Engine. And that system is what's running on that Mac Pro, right? It's one computer and it, sets up a stream. You plug into the thing and it does the And they have a little part of their instructions that say, hey, if you want to stream more out of a commercial product like this, you'd put a cache layer in front of that. You might want to run like Nginx or Varnish or something like that to be able to hold the streaming components. I'm like, oh, that's very interesting. So a month later, I'm in talking and they go, we need to build way more views for a TV station. We need to do it in the next 48 hours. I'm like, ooh, what is this thing, right? So I can see this thing banging around in the email, and Jamie Kinney, superstar solutions architect who ran the NASA relationship, just hyper intelligent guy. He ends up calling in and going, you're in Santa Barbara, right? And I go, yeah. And he goes, how far is it to Pasadena? And I was like, I don't know. Google Maps will tell me. I don't know. He's like, start driving to Pasadena. I go, oh, okay. So
the JPL.
Yeah, we're going to JPL. So I'm driving to Pasadena and I'm on the phone with him and a couple other buddies. And we're talking through I guess they got to run this TV station bigger. And if we're going to do that on Amazon, how will we do it? Well, there's this Adobe live streaming thing. That's probably an easy way to do it. We can get commercial access to it. All right. Well, how many viewers is that set up for? Oh, it's about 100 viewers a time. Well, you need more instances for that. All right, let's have a bunch of instances. So then we start to look at the cache spread. How many instances can that Mac talk to be able to get to enough viewers? And so the big aha is setting up basically a 2-tiered cache. There's so many end nodes that have to exist. You have to have a cache for your cache, which was not all that gnarly, but it had to be done. So we also grabbed the folks at SADA who were awesome and said, look, you got to load test this thing today because I don't want to have the first time we try this when they land the rover. So They hammered the snot out of us and gave us a bunch of traffic. It worked awesome. And then superstar engineer on their side, Quadra Shams, who ended up coming to Amazon, working direct for Charlie Bell. He plugged in, helped out. We built this whole thing, worked great, crazy underload, amazing. We're in the control room. It's 2 hours to landing. And I'm watching people like refresh this screen to make sure that the video stream is still working. It's still working. I'm like, could you please stop hammering my friend? Yes, it's still working. But I'm going, show me that URL that you're using. And oh, this is the NASA TV URL. Oh, okay, cool. What is this URL, right? You're not just going straight to the video stream on our side. No, we have to have the like NASA logo around the outside edge. I'm like, what is it? And they go, oh, this is WordPress. And my skull implodes. I'm like, oh God, we're going to die. We're going to die. So I'm looking through like, they're like, no. You know, you guys wrote this solution material on WordPress. We've got it on 16 giant machines. You're totally good. Load tested this. I'm like, okay, why are you refreshing? Well, we want to do an update that says, hey, now the rover is live. So we're going to change this little block of text in the corner. I'm like, oh, it's a block of text. They're like, yeah, where's that read from? Oh, from the WordPress database. I'm like, oh, well, good. Where's the WordPress database hosted? And they say, oh, there's not very much traffic to the WordPress database because we don't make that many changes. But the 20 M24XLs that sit out front, right, with however many zillion connections at the same time, as if they're not going to just come back and smash the living daylights out of this.
Yeah.
So I'm like, let's look. No, it's okay. It's on cloud. It's cloud. It's totally good. It's on RDS. This is totally good. I'm like, okay, awesome. Let's look at that instance. It is an M1 small, my friends. A single. It has 400 or 500 viewers. I think I may have deployed the only like 64 core monster machine as a read replica of an M1 small to be able to vend all this traffic out to these folks. We did that 20 minutes before live. And then remember the guy Bobek, the dude with the like blue mohawk, who was one of the science guys at NASA. He was in the video. He's super loud, unreasonably loud. So they're in a building right next to our building. And it ends up being a 47-second streaming cache, another cache delay before the video squirts out the other side. And so you hear him go ape and you're just watching the clock. You're like, please, baby, please let these pixels fall out the other side. They were happy. They kept using cloud.
Thank you so much. That's an awesome story. I love it. It actually, I mean, you are just a fast talker and so full of enthusiasm. And listeners, I wish you could see the performance as well. He's just using his hands a lot. It's great. But this actually reminds me a lot of seeing, weirdly enough, although you talk better than he does, Shatner. Because Shatner always ends with this one story when he does live talks of him getting pulled over for speeding while wearing a Captain Kirk outfit. And the police officer saying, live long and prosper, basically. Go get him.
Yeah, give him the Spock handshake. Totally. 100%.
Yeah. So I felt like that. Thank you so much. That's around the time we have today. I want to make sure if people want to follow you online, if they want to hear more cool stories, if they want to learn about SADA, if they want to learn what you're doing with trombones that you have in the background, where can they follow you on the internet?
I mean, there are a couple of people in Ireland also named Miles Ward. They are systematically hosed on the internet as I am proactively capturing all namespace everywhere. So it's at Miles Ward on Twitter. It's linkedin.com/Miles Ward. SADA.com has really an incredible blog, a whole bunch of materials there. And there's our podcast, I think, called Cloud and Clear, that I kind of co-host together with our CEO, Tony Safoyan.
Oh, cool.
A bunch of really great material. Those get produced both in kind of podcast format, but also on video. So you can consume either way you like.
Awesome. Thank you so much. We'll put that in the show notes, listeners. Now is the time of the show where we do Spotlight, where we talk about code or people or projects that have gotten us to where we are that we just want to shed some light on and say thank you. So, Justin Dorfman, what is your spotlight today?
My spotlight today is Linkerd.io. They are a CNCF project. We're having the founder of Linkerd on in a couple of weeks, so I'm very excited. But the thing I love about them is everything they do, whether it's community management or documentation, they just nail it each time. So really excited to have William on in a couple of weeks. So Linkerd.io.
Awesome. Thank you so much. All right. My spotlight today is actually IPFS. I was just remembering working there and imagining building an internet that like actually goes beyond the galaxy. Super, super cool, smart people trying to make the world better in some ways. Super cool team. So IPFS, go to IPFS/IPFS on GitHub. Awesome project. Miles, in the past 2 minutes of putting you on the spot, what has your spotlight become?
Well, Well, I mean, given the story that I told, I think the only rational project to be positive about is our fine friends at Nginx, who have created a monster. It is the Swiss Army knife of web serving. Is it a cache? Yeah, heck yeah. Is it a router? Of course it's a router. Like, what can't you do? And a chunk of very bizarre configuration code inside of Nginx, which is, I don't know why they haven't straightened all that part out, which is probably why the Varnish project exists, to have you be able to even remotely make sense of the madness, wireframe weirdo-ness inside of how an Nginx is set up, but it does do hot magic. So happy to see it be successful.
Thanks so much, Miles, for coming on. I really appreciate it. Hopefully we could just do this like quarterly.
More stories to come, I'm sure.
Yeah.
If you have ideas, listeners, please let us know who you would like to have on this podcast. Again, our themes are cloud native and open source, trying to get those two things together to make the world a better place. Suri and Justin will be talking to Mark at Cubelist. We're really excited about that. If you have any ideas or themes that you think we should touch on, let us know. Otherwise, we've already recorded it by the time this airs. We hope that you have a listen. Going to be very excited. And if you want to show your Curiefense pride, whatever you want to call it, merch will be coming soon. Quite literally. We're looking forward to having merch out there. Get in touch. Justin, where can people get the merch that they want?
Email me, jd@reblazed.com or jdorfman@curiefense.io, and I'll send you over the link to get your free swag, stickers and shirts.
We hope you enjoyed this podcast. Thank you all so much. Catch you next time.